In this presentation, we're going to modify an earlier theory and then evaluate it. In our earlier theory, we postulated that more study results in a higher exam mark. However, we also argued by looking at the slope that each hour adds the same percentage in the exam, and we argued earlier that this wasn't particularly realistic. So let's postulate a new theory, because we think that students would tend to gain less and less as they studied more. And so this is represented by this nonlinear relationship, by a curvilinear line rather than a straight line. And in that situation, the slope actually falls. So we can see this by looking at the first 4 hours, which yields about 40%, and then another 4 hours only yields 10%. So it's quite clear that the gain in exam scores is actually falling as the number of hours of study undertaken a week actually rises. So we can show this by looking at the slope as we progress up the curve. So in this case, the slope gets flatter and flatter and flatter, as illustrated by the slope of the tangents that are moving from the early hours of study to the later hours. The analogy you can use here is a picture of somebody walking up a mountain. Initially, the mountain is very steep, then the slope flattens out and eventually becomes almost horizontal. So, it becomes easier and easier to go up the mountain. Now, what are the theoretical implications of this new line? Well, we've seen that more hours of study still implies higher marks, but there are diminishing returns experienced as the number of hours increases. So students are gaining less and less from the same additional effort. So how would we explain this? Well, we would expect that initially we gain quite a few marks from the earlier study, because often we have superficial understanding which is quick to gain, but then it takes longer to get a deeper understanding. We also observe that some topics are easy to learn, and so we gain marks relatively quickly, but it takes longer to get to understand the more difficult topics. Alternatively, we could argue that extra study brings on fatigue, both mental and physical. Or we could argue that as we study longer, so our minds wander to the things we could be doing instead of studying. And so that means we concentrate less and less as we study longer and longer. Now, in all these situations, of course, we still theorize that all other things remain the same. So, in other words, the ceteris paribus conditions still apply. And an economist would ask, what would happen if these ceteris paribus conditions changed? Well, generally what happens when ceteris paribus conditions change is the relationship or the curve will shift. And so you'll remember that the ceteris paribus conditions were dictated by this distance, where the intercept of the line cuts the axis. So initially, remember, we argued these conditions would allow students to gain 20% for the exam without any study at all, whereas now what we're postulating with students from, let's say, if the exam were easier, would be able to start off with 30%. So the intercept term now has been changed. So it shifts the curve upwards. However, of course, any negative impact, like the exam becoming more difficult, would shift the curve downwards. So the ceteris paribus conditions, changes to ceteris paribus conditions, alter the position of the curve. They shift it. What about changing the slope? Well, that relates to a change in the efficiency of learning per hour. So there's no change in the intercept term. We're still stuck at 20, but as study progresses, so in this case, it's becoming less efficient because of poor teaching. Students are spending time trying to organize the references they've been given or the instructions they've been given, and since they've been poorly given, they can expect to spend more time studying that same topic than they were in a situation where the teaching was better. And that's still the case as the number of hours increases. Incidentally, of course, anything good teaching would have the opposite impact. It would make teaching more efficient. Make study more efficient, so the curve would take on a higher slope at each level, at each hour of study.